Uh, Good morning, everyone. Thanks for coming. So, we'll discuss the incident response for AI agents. So, the agenda for today's talk would be why does it matter? I mean, why agentic AI matters, and the challenges that we have, the threat taxonomy that is associated with it. Then, the life cycle remains the same for the IR that we follow usually, and post that will move what evidence is to be collected for forensic investigations. So the primary question that we have here is why this matters now. It matters because we are moving. Okay. It matters right now because we are moving from assistants to agents. So now all the agents that we have in the industry are fully autonomous. It can make any changes to your system, whatever action that you want it to be performing. So the key questions that I want you to have throughout this talk would be how to detect it quickly, how to contain its agency, prove root cause with evidence, recovery safely, and meet legal or regulatory requirements. So what breaks in the traditional IR? So the traditional IR usually follows login failures, malware, ransomwares, whereas when we discuss about AI agents, the scenario completely changes. Let it be prompt injection, pause in database, or agent memory, tool misuse, multi-agent or unsafe autonomous actions that you see. What makes agentic AI different? I mean, why does it different from the traditional systems that we have? Why is it? Anyone can?
Keep like this.
Okay.
Keep like this.
That should be on.
Okay. Anyone? I mean, why is it different from?
It is non-deterministic in nature.
Okay, non-deterministic in nature. What else?
It has a lot of power and a lot of places to be used.
Okay. So let's begin with non-deterministic in nature. What challenges does it bring from security perspective? Let's say if it's non-deterministic in nature, what challenges does it bring from security perspective?
No guarantee of fixed working.
Okay. So technically we can say agents are inauditable. Audit means something which can be proven. Example, x equals y and y equals x, which can be proven. So can we say that the actions or decisions taken by LLMs or AI agents are inauditable? It cannot be proven. Example, let's say you deploy agent to take certain actions in your SOC environment. Example, block an IP, hash or anything. So the initial response that agent gave was something different and the action it took was related to that. But later when you try auditing it or try getting the same output, the non-deterministic nature of the agent or let's say the LLM will somewhere create problem where you will not be able to trace its route. Okay? Prompt injection. I mean, no matter how much guardrails we deploy, the problem will still pertain and it cannot be solved. So the contributions of the framework that we have created is it discusses about threat taxonomy, severity metrics, specific logging, playbooks, toolchain, and tabletop scenarios. Okay, threat taxonomy for agents. So there are 8 taxonomies or the classifications that we have created. So first one is data integrity. Second is model manipulation, prompt based injection attacks, inference or output input, resource exhaustion, supply chain multi-agent risks, and inadvertent failures. So what does it mean, and I mean how do you see it? What other challenges? I mean how does it relate to this threat taxonomy? Example, prompt injection. Let's say from a security perspective, how does your prompt become a challenge in SOC environment when we deploy any agents?
It might also perform inadvertent actions, right?
Okay, this is one of the challenge. Other things?
It might go wrong.
Wrong, okay. It might go wrong.
It might go wrong, right? So one thing, you might ask it to block an IP, but it might block some other IP.
Right.
So that might cause some production issues or something else. Or
Of course it
block
can.
a user from accessing the network or whatever it is. So there are a lot of probabilities that you can think of in different taxonomy.
Okay. Okay. And let's say, is it like, there is a challenge again associated with it, like it can reveal your sensitive data of your organization. The logs may be public.
Yeah, maybe if it has external exposure or something. So if it is only accessible to your SOC team and it is not really exposed to the external world, then you have any sort of issues. Unless there is an internal threat or some lateral movement happens within your organization and somebody gets access to it, then there will be a probability of some sensitive data which might be holding get exposed or something like that. But unless it is not exposed to the internet or exposed to some people who are not intended to access it, then you will not have any such problems, right? And the only problem comes in when somebody does or somebody injects a prompt that is malicious, and that's when it might go rogue or it might give some inadvertent results or something like that. You can correct me if I'm wrong.
Yeah, you're correct. Okay, the major incidents that we see pertaining to agents or LLMs. So prompt injection remains the top. After that, the input-output downstream that we see. Okay, and third would be multi-agent risks. Okay, so direct and indirect prompt injection is something which the industry is currently trying to solve and finding it very hard. At the same time, let's say you deploy agents in your environment or LLMs are being used, let's say for general purpose only. I may send my log to write a triage report and submit it wherever it is required. Now the problem here is, are we tracking the logs of the agents or LLMs? We are not. Do we have tools for it? We don't have any. The industry, the traditional logging system or the schemas that we have doesn't even apply to the agents that we are seeing right now. LLMs does not follow the same schema that the traditional systems were following. So there lies the challenge. Neither there are any tools to monitor the actions or the logs that are being created from the agents, nor there are any industry is ready for it to accept it. So there lies a big challenge, and at the same time, the other challenge is that agents itself brings inauditable in nature, and that's a bigger risk that security industry is facing right now. So the traditional IR lifecycle remains the same, starting from preparation, detection, analysis, containment, recovery, and post-incident. The only thing that changes herein, the traditional system were having different attack mechanisms or attack vectors, whereas the attack vectors changes for agents. So let's say for preparation stage, we need IR plan. So first of all, we are not even ready with the logging tool, what tools we require. So IR plan is required, then logging, kill switch, and playbooks. At detection phase, we need behavior drift, tool misuse, output policy violations, analysis. And at the analysis, now here comes the most important part. What evidence is to be collected? What schema to look after, let's say if something goes bad in the environment? And how do we correlate it and how do we vet it? There is no proven mechanism where we can say, okay, if something goes bad, this is the risk which lies there.
Maybe you monitor the actions of your agent.
How do we monitor that?
Yeah, so that is something we will have to think about.
Right.
So when you monitor the actions and when you monitor the role of the agent, and if anything goes beyond it, right? If it is performing some other action that is not part of its role, then that is something that we wanted to monitor and get alerted on, take care of.
Correct.
So what if you place the reasoning cases? What if you monitor the reasoning cases?
Sorry?
What if you monitor the reasoning cases?
What?
Reasoning.
Reasoning cases.
Yeah.
And how do you monitor that?
I don't know.
Because traditional SIEM tools does not follow your agentic, it does not usually track the locking mechanisms or locking systems of your agents, right? You pass on any prompt, it will not be recorded. It will only take actions, your agents or LLM will take actions, but it will not be recorded with your traditional SIEM tools that we have in the industry. No matter, there are tools like runtime security, but again, I have tried a couple of tools, none of them are working as expected, which can show the exact activity the user performed, or which can be proven end to end, like which is transparent. And now, okay, let's say in future, maybe efforts will be made to develop a tool or something, but what exactly, let's say your agent is somewhere compromised, okay, your orchestrator is compromised. In such cases, what to contain and where to contain and at what level, the business implications that it may bring. Example, your orchestrator took some decision to segregate or contain a land, okay, which is critical to the business. So it may bring multiple risk at higher level, which cannot be reverted back. At the same time, it cannot be proven as well, because the agents that we are using is non-deterministic. So this is the reference architecture, okay, so you can go through it and okay, I'll explain. So what it does is, let's say you pass on any prompt, so somewhere it should be tracked, every token should be tracked, what actions the agents are taking, where all it is, which all applications it is reaching out to, okay, and what all endpoints it is touching. So all this has to be tracked, okay, and what modules. Now we have 𝗦𝗲𝗃. How many of you heard about 𝗦𝗲𝗃? Okay, so 𝗦𝗲𝗃 is something like we have 𝗦𝗲 attack framework for traditional systems. So 𝗦𝗲 attack framework will be used here to map the threats, okay, and accordingly we can take decisions, where to correlate and how to contain it. So at the preparation stage, what we should do and how we can do it. First of all, we need to define the AI/IR roles, like what roles are needed. Example, one would be IR commander. What other roles are needed if something goes bad in the environment? So one would be your IR commander, the other would be your AI engineers and the data science engineers, who can look into the codes and exactly tell you where it is going and how it is going. At the same time, we don't have the problem again, loose back, same, there is no mechanism to track the log itself. Okay, do we have a playbook? Let's say there are multiple threat vectors pertaining to AI systems. Do we have any playbook which we can say, okay, if something goes bad, this is the action that we are going to take? Forensic readiness, like to track what exactly happened and how it has happened. So at the data ingestion layer, we need to collect the input-output logs, model state snapshots, and the confidence or uncertainty metrics. And how we can track it? Through guardrail. Since guardrail, somewhere all the prompts that you provide, it will go through the set. So every prompt that you provide will go through the guardrail, okay, and which we can use it for tool uses, to log the functions, then agent decision steps. When we chat with ChatGPT, okay, we pass on any prompt. So okay, there's a question that I want to throw. what's the deciding factor or major difference between Gen AI and agents? Do we call ChatGPT as LLM or agents itself? How do you define it? Chatbot. How do you define it? Anyone? Oh.
So we have 6 layers of AI, right?
Right.
So layer 5, that Gen AI part will come. Layer 6, this agentic AI will come. So
Okay. So how do you define? I mean, if ChatGPT is your agent.
Layer 5 would be.
Layer 5.
Yeah.
So
I know, so far I know.
so layer 5 would be your LLM, right?
Yeah.
Okay, LLM. But when you, let's say you give any prompt, so you will see multiple agents functioning together. Example, you give a prompt to look for the best restaurants around any particular area. So multiple agents will run parallelly to take decision, and there will be a collective response taken from all the agents, and it will be sent to the orchestrator, and then the output will be provided. So how do we call it? Is it a agent, multi-agentic framework or something?
Multi-LLM framework.
Multi-LLM framework. So SLMs, multiple SLMs.
So answering your question, basically the difference is in Gen AI we don't have the LLM does not have autonomous access to tools or different, like for example ChatGPT itself is an agentic system now, because you can generate an image, you have web search tool and multiple tools that it automatically calls based on the request. So the main difference is this autonomous behavior and tool integration, MCP. So that comes mainly in the agentic layer. There are multiple agents that can orchestrate each other. So like that is the main thing.
That's true. ChatGPT is a multi-agentic framework being presented to the industry as LLMs. Yeah. So at the detection phase, what we should detect exactly? Behavior anomalies. How do you, let's say in terms of LLMs or agents, what would be your behavior anomaly? Example, one of the primary example that we have been discussing since starting was blocking an IP. The other would be, let's say your agent gave a trials report where it shows these are the recommended steps. Okay, let's say the initial recommended step was, okay, your system is infected with something and we need to reboot it or somewhere reset all the credentials, or some of the recommendations will be there. So when you pass on there will be a confidence score check to check if the initially generated response by the agent is how confident the agent is in the response. So there will be a comparison, and if there is any mismatch or the confidence is low, then another response will be generated. In such cases, again your recommended steps will change. Okay, so when you give this recommendation to anyone whose system is compromised or any action has to be taken, in such cases it will become really difficult for us to identify what exactly the anomalous behavior would be. Okay, second would be prompt injection. Okay, any action, let's say as a developer, someone is writing something and the developer has given full control to the agent, which can make any changes to the system. Okay, example, while using Cursor AI or Codex, you would get a prompt where you can give access to the Codex or Cursor AI to make any changes to the file. Agents can make any changes. In such cases, what okay, so in such cases, what it will do is it make any changes to your system files as well, leading to data leakage or any other anomaly.
I have a question. Hello. Yeah. So I was asking, in this implementing while implementing this garden, how much latency is compromised, and how do you ensure the latency compromisation is minimal?
No, we are not deploying any guardrails here. Okay, that's the discussion. The major objective of this talk was to provide an idea where the industry is lagging. We don't have any tools to log the activities of the AI systems. Okay. Okay. How do we analyze the logs? There is something called as Open Telemetry AI system for AI. Anyone has heard about it?
Telemetry.
Open Telemetry.
Telemetry is there, right?
So what it does is, how we have schemas in the logging for traditional systems. Similarly, OTEL or Open Telemetry has given a schema for AI systems. So maybe this is something where we can look after to understand what exactly to be done if there is any compromise with your AI systems.
So, have you used 𝗬𝗂𝘃 also?
Sorry?
𝗬𝗂𝘃 is also there, right?
Yes, we can.
Yeah.
Yeah.
𝗬𝗂𝘃 is also intended for logging metrics. Yes.
Logging metrics it does, but the widely industry-wide accepted would be OTEL, Open Telemetry.
So you said taking current model snapshot, so there could be numerous attacks. So will it be feasible or economically viable to take snapshot each time?
It is currently it is not feasible, okay, but somewhere we will have to look into it how we can optimize that problem. We cannot take let's say in security environment there has to be a defined logic where the snapshot should be taken. If example, if there is any action which is being taken by the agent or LL, in such cases only snapshot should be taken, otherwise it's not required. Otherwise the snapshot size somewhere will go very high, so that will incur more cost to the company. So okay. How do you define severities for alerts or any attacks related to AI systems? Okay, so that becomes a bigger challenge for the industry. Somewhere the industry has to look after what risk is associated with each and every action that LLM can take in security environment. So that has to be weighted, and according to that we can create a security matrix. There have been attempts from other organizations or researchers to map it, but none of the efforts were industry accepted. What containment action we can take? What is soft contain? So soft contain means rate limit, input filters or output guards. Privilege reduction would be revoke tools, sandbox actions or human approval. Isolation means isolate the agent, block communications like multi-agent communication from the orchestrator itself. Or hard stop, kill switch. If something goes bad, let's stop it now. Okay, no further action the agent may take. Any questions on this?
Take the questions at the end.
Yeah, sure. Okay, at the recovery stage, if your model is compromised and somewhere it will hold your PII data or health information data, so in such cases, if there is a data leak, how we can retrieve the data which has been somewhere leaked. So that has to be worked on, like restore integrity, prevent reoccurrence. So when your data somewhere, when your agent is able to interact with your real-time data, somewhere the integrity becomes another challenge. It may introduce new logs into the manufactured logs into the system. Okay, so that is another challenge. Here you can see the IOCs that we can map to at different stages. for data poisoning, we can look after model performance or bias shift in output, okay, or IPs that we can see, or anomalous states in training data or data integrity check failures. Okay. Similarly, at model manipulation and exploitation, we can see misclassifying normal inputs or logs, so perpetrated inputs, prompt injection. We know, I mean, what exactly to look after. Okay, I mean, how to define a playbook for, let's say, I've taken one example for prompt injection. So what exactly we can do at the detect phase? We can we need to define patterns for jailbreak, system prompt leakage, or unexpected tool calls, or regex or keyword matches. Contain phase will include input-output filtering, privilege separation, revoke sensitive tools, or human in the loop. And recovery would be your prompt hardening, stronger input-output guards. The governance regulations that we have around it. So we have NIST AI RMF, then ISO 42001, then 238. So these are the laws that we have. This is. So these would be the key takeaways from the today's session. Questions?
Yeah, thank you. Any questions?
Demo isn't working. Demo isn't working.
It's not working.
No.
Okay. Because we have questions. So
Anybody having any questions?
Okay.
No questions?
okay.
Okay. Thank you. Thank you.
Thank you so much. Please give a big round of applause.